Okay, class for procedure 5 is test for volume conservations. This particular one, I'll be dropping the materials on the group chat. I've already done this before, so that one is actually not a problem. Now, if you look at the data table number, I think data number 6, it said mass of volumetric flux plus aliquots after mixing. You don't really need to stress yourself for this particular procedure. Yes, just like I told my students, you don't need to stress yourself. Listen, whatever your answer, number 2II, you know we have 2I. 2I is mass of the flask when it is empty, and 2II is mass of the flask when it is with distilled water. Remember, distilled water is actually was symbolized by A. So anytime you see A, we are referring to water. Anytime you see B, we are referring to ethanol. So what we're simply going to do here is that the answer we got from 2II, that is 22 grams, we're going to record it here as number 6I. I repeat, the answer we are going to get as 2II, 22, right? We're going to record it here. But you don't want it to look as if you did not carry out the experiment. So instead of it to write 22 on the, you can just decide to write 21.90. Do you get? Now, I repeat, this 6I, mass of volumetric flask plus aliquots after mixing. 2II is mass of volumetric flask. You see the same volumetric flask that we're making use of in this number 2 that we're still going to use in this number 6. So instead of carrying out this procedure 6, you can just come back. The values you got for 2II, that is 22. You could choose to rewrite exactly the same way as 22, or you could decide to increase or reduce the value small. Okay, so I wouldn't want to write 22 exactly, so I will opt to write 21.90 grams. Now remember, B is ethanol. Alright, so procedure 3, the answer we got here as 20, see the same thing we are going to get, it's the same thing that we're going to get as 6II. So in this case now is 20, in this 6II, instead of it to write 20, you could just write 19.98, or you could just take it up a bit. Okay, so with that now, we've gotten the values for number 6. Okay, we've gotten the values for number 6. Now, after procedure 5 is test for volume conservation. That particular one will be done. I already sent in the material, so you could just check the materials and then solve for yourself. The materials are quite self-explanatory. Okay, now procedure 7. Procedure 7, they said determination of the density of the mixtures. Determination of the density of the mixtures. Now listen, class, listen and listen very carefully. They said after thorough mixing. Okay, but before we proceed to determination of the density of the mixtures, which mixtures are we talking about? If you refer back to procedure 6 actually told us the mixtures and how we can get it. In procedure 6, which has a subheading of prepare liquid mixtures, you see that they said use the calibrated transfer pipette and prepare a series of mixtures of 2 liquids with varying composition. I repeat, use the calibrated transfer pipette and prepare a series of mixtures of 2 liquids with varying composition. Now the varying composition is this. Now these are the 2 liquids, A plus B are mixtures. So in these first suggestions, they said take 15 of A and 5 of B. Okay, now listen. This is what I have Lemia flask. You take 15 of A. A is water. Take 15 ml of A. Okay. Take 5 ml of B. I repeat. Take 15 ml of what? A. A is water. Take 5 ml of what? B, which is ethanol. Mix it in a Lemia flask. mix it first in a Lemea flask. When you're done mixing, transfer when you're done mixing, take that mixture, this mixture now, transfer it into 10 ml volumetric flask and weigh. Why are we transferring it into this case? Because this volume, we had already calibrated this volume to be 10 ml. Do you understand me? Except maybe in the lab they might give you guys 25 ml or something bigger to actually make use of. But in real sense, you're to mix these two mixtures separately in an Lemea flask. Bring 15 ml of A, bring 55 ml of B, put it here, and you shake it. That means inside this Lemea flask, you now have a mixture of A and B. A has 15 ml and B has 5 ml. Now, expectedly, the volume is supposed to be 20, all right? But then we are going to carry out calculations to check the volume if truly is going to be 20. Do you understand? Because when you carry out mixtures of two different liquids, right, 15 of A, 5 of B, that's two different mixtures, right? So you expect that 15 plus 5 is supposed to be 20. Yes, that is the expected stock volume. But in real sense, after the calculations, we're going to see that it's not going to be up to 20 because volumes will not be conserved. Because theoretically, when you mix two different kinds of liquids, volumes is actually not always conserved. So after you must have finished mixing 15 of A plus 5 of B, make sure you shake thoroughly. Now transfer this mixture, take 10 out of this and fill this. You take 10 ml out of this, fill into this case. Take 10 ml from here and fill here because this flask is 10 ml. Once you do that, I've already done this before now, so we're going to get something like 21.9. Once you do that, you can now solve for the density of this mixture. The density of this mixture is going to be mass of the mixture all over volume. How do we get the mass of the mixture? Remember, this flask, we had already calculated the mass of this flask when it was empty to be 12 grams. And now we actually added a mixture of A and B into this flask and we weighed and we got 21.9. So in real sense, the mass of the mixture inside this flask is going to be 21.9 minus 12. That becomes the mass of this mixture. And what is the volume of this flask? 10. So the mass of this mixture now becomes 21 minus 21.9 minus this. Let's say it is 11.9, right? Divided by 10. That is 1.19. That is the answer, the density of this first mixture. Okay, so we are done with this explaining the procedures. If you have any question, you could just drop your questions on the comment section, and of course I'll be willing to answer your questions as soon as possible. But however, if you are not on our group chat, okay, if you are not on our group chat, my phone number is 07038101576. 07038101576. Send me a message on WhatsApp so I can add you to the WhatsApp group, and so you can see the calculation, because I've already done the calculations, a kind of a sample calculations. Now the next experiment is experiment 7. Class, that experiment is very, very simple. Okay, so the procedures, I don't want to spend time to be explaining it. It's basically titration. So titration is very, very simple. However, the calculations, I already dropped it on the WhatsApp group. So thank you for having me. My name is Delzi from Delzi and White Tutorials, and by God's special grace, the chairman CEO of Delzi Scholars Educational Group. So thank you for watching, and please like, share, and subscribe. Thank you.